encoding the entire sequence of ASP2. This protocol was compared to two other protocols, an homologous priming boost protocol where the animals received 2 doses of adenovirus, and a protocol where the animals just received a single immunization with adenovirus. At the scheduled time point, we evaluated the cell-mediated response, and further, the animals were challenged with the Y strain of Trypanosoma cruzi, and the mortality and weight, the parasitemia and mortality was followed up during 50 days. Okay. The spleen cells were harvested and pulsed with dextramer corresponding to the immunodominant epitope. As depicted here, the mice that are primed with influenza virus showed a significant higher number of specific CD8 T cells. In addition, by intracellular cell staining, when the cells were incubated, labeled for CD107, granzyme, interferon gamma, and TNF-alpha, we observed that the subpopulation of CD8 were quite different among the different protocols. Moreover, the number of positive cells for granzyme, interferon gamma, and TNF-alpha were higher in mice that were primed with influenza virus. Interesting, while a single immunization with adenovirus was able to reduce the parasitemia, the animals that were primed with influenza virus showed a higher survival rate when compared to the other groups. In conclusion, our results showed that a priming with influenza virus was able to shape the immune response and to improve the survival of the animals challenged with the Y strain of Trypanosoma cruzi. However, the NA38 vectors used in the experiments have some disadvantages, such as the size constraint regarding the foreign sequence that can be inserted to the neuraminidase gene, and the virulence of the recombinant vectors. Therefore, the search for replicative, defective, or attenuated virus is important to be pursued. In a very elegant study, Dr. Yoshihiro Kawaka demonstrated that a neuraminidase sequence could be partially deleted and the coding region replaced by a foreign sequence. Those partially deleted neuraminidase segments can be efficiently packaged into the viral particle. In addition, the recombinant viruses are highly attenuated in mice, able to elicit humoral response, and able to protect the mice against the challenge with homologous wild-type strain of influenza virus. However, some aspects about this virus remain unknown, such as the cell-mediated immune response, the inflammatory response, and the safety to immunocompromised host. Therefore, aiming to answer some of those questions, we constructed a virus named vNA-Δ virus, named Delta virus, in a PR8 background by reverse. These viruses are constructed by reverse genetics. This virus carried a partially truncated neuraminidase segment corresponding to only the first and the last 150 nucleotides of the code region, separated by a spacer sequence. As expected, when the mice were inoculated with an otherwise lethal dose of Delta virus, we observed no weight loss, and all the animals survived the inoculation. In addition, the viral loads in lungs of mice inoculated with Delta virus dropped dramatically at day 4 and became undetectable at day 7. The immunopathologic lesions are very important during the infection with influenza virus. As showed here, at different time points we evaluated after inoculation with influenza virus, we observed that all the inflammatory scores were significantly reduced in mice inoculated with Delta virus, in contrast to those found in mice inoculated with the control virus, the wild-type virulent PR8 virus. In addition, the lung lesions were significantly lower in mice inoculated with Delta virus when compared to those found in mice inoculated with PR8 virus. These results, lower inflammatory score and lower lesions, strongly suggest that those viruses are really safe to be used in vaccine approach. In addition, we observed that the influx into lungs of neutrophils and mononuclear cells were lower in mice inoculated with Delta virus. These results are related with the reduced myeloperoxidase activity and N-acetylglucosamine levels in lung of mice inoculated with those viruses. These markers are related respectively to neutrophils and mononuclear lesions. Finally, we found that the influx of leukocytes into the bronchial lavage fluid and protein and nitrite were reduced in mice inoculated with Delta virus. We also assessed some cytokines in lungs of animals inoculated with Delta virus. As shown here, whereas the levels of interferon beta and interferon lambda were higher and sustained in mice inoculated with PR8 virus, we only observed a peak of interferon beta production in lungs of mice with Delta virus at day 1 post-inoculation. In addition, the levels of interferon gamma, TNF-alpha, interleukin-1 beta, and interleukin-6 were only augmented in mice inoculated with the wild-type PR8 virus. Regarding the acquired immune response, it was evaluated in following protocol. Mice were inoculated with different doses of Delta virus, 1,000 and 100,000 PFU, and a sublethal dose of PR8 virus. As shown here, the level of EGA and IgG in bulk of mice inoculated with PR8 virus were higher than those found in mice inoculated with Delta virus. Regarding the EGA, the levels were similar in mice inoculated with either dose of Delta virus. In contrast, the levels of IgG and BALF were higher in mice that received the higher dose of Delta virus. In contrast, the seric level of IgG were similar in mice that received either the higher dose of Delta virus or PR8 virus. In contrast, they are higher than those found in mice inoculated with the lower dose of Delta virus. As expected, the hemagglutinin inhibition titers found in mice inoculated with the higher dose of Delta virus or the PR8 virus are similar. In contrast, they are higher than those found in mice inoculated with the lower dose of Delta virus. As expected, when these animals were challenged with a little dose of PR8 virus, we observed that only the animals that were inoculated with the lower dose of Delta virus harbored, all the animals harbored virus in their lung. Regarding the cell-mediated response, we observed that the number of specific CD8 T cells to NP protein, that is the immunodominant protein for cell immune response in influenza, were similar in mice inoculated with the higher dose of Delta virus and the PR8 virus. In contrast, the number of those cells were lower in mice inoculated with the lower dose of Delta virus. When these animals were challenged, when the animals are challenged with PR8 virus, we observed that only the animals that received the lower dose of Delta virus showed weight loss, and some of them died. In contrast, the animals that were primed with the higher dose of Delta virus showed no weight loss, and all the animals survived the challenge, as corroborating the previous results of Kawaka. Interesting, if you assess the number of CD8 T cells after the challenge, we observed that the animals that received the lower dose of Delta virus showed the higher number of CD8 T cells when compared to the other groups. Finally, we evaluated the safety of those vectors to immunocompromise the host to innate immune response in Myd88 mice and acquired immune response in Rachou mice. As expected, the animals that received the knockout mice, Myd88 and Rachou mice that received PR8 virus showed dramatically weight loss and died. In contrast, all the Rachou knockout mice and most of the Myd88 mice inoculated with Delta virus survived the challenge. It's noteworthy that the animals were inoculated with the sublethal dose of PR8 virus and challenged the animals with a one log higher dose of Delta virus to really test the safety of this vector. In conclusion, recombinant influenza virus carrying truncated neuraminidase gene cause mild infection with reduced lung inflammation in wild-type mice. Delta virus elicits a strong local and systemic humoral and cellular immune response. Recombinant influenza virus carrying truncated neuraminidase genes are safe even to immunocompromised hosts, although more studies should be performed in Myd88 mice to explain why some of those animals succumbed after infection. Moreover, our results give support to the use of those recombinant influenza virus in development of safe bivalent vaccine against influenza and other pathogens. Indeed, we are currently constructing influenza virus harboring trypanosoma cruzi sequence, and those viruses will be evaluated in heterologous prime boost immunization protocols aimed at the development of vaccine against the Chagas disease. I would like to thank you, our collaborators, and to you. Thank you very much.
Thanks a lot, Alexandre, for the very interesting talk. We have time for one question. Please.
Thank you very much for your presentation. I would like to ask you do you have any evidence of pathology scoring of the lung lesion for your research work? Pathological scoring of the lesion.
Okay. I don't know. In this study, we insert a spacer sequence. Is a junk sequence. Correspond to the sequence code no protein, exactly to avoid the interference of the foreign things to be inserted. Regarding the ASP2 sequence, the role of ASP2 during tuberculosis infection is unknown, as this protein is expressed only during the intracellular phase of the infection, and it's a very, very strong inducer of cell-mediated response, poor inducer of humoral response, but the function to during the infection of T. cruzi is currently unknown.
No scoring here. No scoring of the lesion.
No score. In the score is performed here only with
of the lesions in your pathological studies.
yes. Yes, I performed histopathology studies in mice inoculated with influenza virus. Okay, about the vaccine with the prime boost protocol. Okay. Okay. Regarding the prime boost protocol with influenza adenovirus, we observed that the mice that received even a single immunization with adenovirus showed reduced histopathologic lesions. But what's the problem? We evaluated only the liver and the heart. During the preparation of the material, we lost the gut. And the whey strand is not very cardiotropic. The parasite went most to the gut. We guess we cannot prove that the lesion should be reduced in the mice that received the heterologous prime boost protocol. But I cannot prove because we have no data to corroborate these assumptions.
Thank you very much.
Okay.
Thank you.